The sixth and final step of our bootstrap procedure is to compare the observed statistic to the distribution of statistic values we just created. If this observed statistic is big enough, greater than 95% of the bootstrap values, then we reject the null hypothesis that the two conditions are the same. To visualize the distribution of bootstrap statistic values, let's make a histogram of stat D. Remember, in the histogram, we showed the number of counts on the vertical axis and the statistic, the maximum absolute value of the ERP difference on the horizontal axis. If we compare this distribution of bootstrap statistic values to our observed statistic value, we see that most of the bootstrap values are smaller than our observed statistic. This visualization suggests that our observed statistic is unlikely to occur in our bootstrap distribution. To quantify this observation, let's compute the following. Let's find where stat D is greater than our observed statistic stat. We'll then compute the length of this function. And what we find in this case is that there are 12 bootstrap statistic values that are greater than our observed statistic. We can convert this value 12 into a proportion. To do so, let's repeat the previous command where we find the number of values in our bootstrap distribution of the statistic, stat D, that are greater than our observed statistic, stat, and then divide by the number of bootstraps we perform. In this case, we know the value is 3000, but let's instead use the command length of stat D. We find in this case a value of 0.004, which suggests that only 0.4% of the bootstrap values are greater than our observed statistic. This visualization, as well as these calculations, suggest that our observed statistic is very unlikely to occur in our bootstrap distribution. We therefore reject the null hypothesis of no difference between the ERPs of condition A and condition B. This result helps illustrate the power of the bootstrapping procedure. We proposed a complicated statistic, in this case, the maximum absolute value of the difference between the two resampled ERPs. For this statistic, we don't have an obvious formula to decide whether the resulting statistic is significant or not. To determine the significance of our statistic, we employed a bootstrap procedure, and we can perform this bootstrapping even for the relatively complicated statistic. The bootstrap procedure is a powerful approach to compute statistical significance of complicated quantities.